Cool. I think we're ready to start. Just a quick session. So I mean, this is the stuff that Craig shared as an example. Sorry, with these because I was just playing with these now, and I was just trying to make sense of these, right? And I kind of realized that the way that he built these, it makes a lot more sense. I think what he's trying to do here is he's trying to do a control plus one, right? Um, so if I go to here and open this app, um, the way that I was thinking about doing this, right, is, you'll do, and we can do this with a plus one as well. So with the increment gate. So this is a plus one. So I was thinking kind of like you do it like this in this register, and here you do nothing. And so what you're going to be doing is you're going to be doing a control swap between this and this gate, and then a control swap between this wire and this wire. Gate and gain, right? And there you go. I mean, that's the that being the idea, right? And so, what you would get here is a basically it's not what I expected. Huh. So you should get these 0, 1, right? And then if you the other one, if you do these, yeah, if this is 1, then it's 0, 1. If you control it on 0, then it's going to be 0, right? Yeah, makes sense. Now, I think the way that he thinks about this makes more sense because he's come up with a so the way he does is he sandwiches these with swap gates, and I think what this achieves is that you're not entangling the bottom qubit, the bottom two, because now here you basically got like a mess, an entangled mess, right? If I do these, so this is incoherent, this is kind of like, yeah, basically, if you do these like basically not like these, but like I copy those columns and I move them here. So what I'm doing is effectively I'm switching the wires first. I mean, this is the target register, these 2 qubits. I'm switching them first and then switching them back up. So the way this works is if it's a 1, I'm going to route these 2 down here. I'm going to apply the plus 1. And then I'm going to swap them back up, right? And if it's a 0, though, here, if it's a 0, then none of this will happen, and this will just, kind of go. And now this is not entangled anymore. No, that's entangled. Wait, God. That's stupid. Why is it working though for him? It's because of the states, really. Because this is not entangled in here, but it's because of maybe the phase correction is really needed there. That doesn't make any effect, any change. Maybe this does have indeed something to do with these. So these being like his comment about the eigenstate thing, right? So if I would do this and I would do this, oh, there you go. Oh, this is brilliant because, okay, this is brilliant because what it's doing, what it's saying is like, okay, so if there's going to be no rewiring, right? So if it's a 0, that's an interesting thing to explore, right? I mean, if it's a 1, then we're gonna kind of rewire stuff in here. So this means this 2 will go down, get the plus 1, go up again, and so on and so forth. If if this will be 0, what will happen is that because this will make no effect, because this has no effect on this state, then there's no entanglement. This is this is genius. Okay, now okay, so at least I understand now where is this coming from, but which kind of makes the task impossible in terms of like, yeah, well, if you know, like you're not supposed to know what this is, right? Like if, yeah. Now he claims also what he's saying is that if it's not, if you don't do it this way, then interference with these won't just work well. And we can try this now. I mean, first of all, let me try. So this is true, right? So if I just do this, and this is the QFT, right? So you've got this state. And if I apply a +1 gate, and I take a look at this state, you basically have the same. Because what the +1 gate does is it transforms 0, 0 into 0, 1, 0, 1 to 1, 0. So that could as well, it doesn't have to be these, right? It could just be 2 Hadamars, couldn't it? Like, couldn't it just be like this? Like when these work as well? I think that this will work. This should work. And it should work in his circuit if I replace these by Hadamars. And if I replace these here by Hadamars, because we're like, he's just basically uncomputing the stuff. Now it doesn't work because it's not really uncomputing the whole thing. So there's got to be something with the +1 transforming the 0s into 0, 1, the 1, 1 into 0, 0, and all that stuff. So this is not an eigenstate of. It's an eigen. So that doesn't work. Now this is an eigenstate because this will become 1, 1. I mean, it does add, it actually adds a global phase. Because this is turned into 1, 0, and so the 0, 0 becomes 0, 1. How does that not, how does that turn to be like these? Isn't that like it's a +1, so it turns the 0 and 1, 0, 1, 0 to 1, 1. So why isn't the, these I don't really get. This I really don't get. Why is this working? Like with the 2 Hadamard, it should work as well, but it doesn't work in his case. Now, I think the way he's doing this, but the reason he's doing this is because that's why he's actually doing this, is he's creating some entanglement in here. He's creating some entanglement in here to test the stuff up here as well, I think. Well, that's definitely a funky thing. But I guess this is intuitively what's happening, right? Then he goes ahead and does a control -1 just to uncompute this whole block, right? Because he's just, he's just uncomputing these, because what he wants to prove with this big sandwich here is that you get everything off in here. That means you've uncomputed the function. So it means you've tested whether these really works well, because if you didn't design these well, let's see, if I, for example, do this, right? I go back to what he does here and take these two off the circuit. Well, there's definitely something. I have the impression I messed up. Oh, that is sorry. That is the inverse of the QFT that should go here. Definitely. There you go. And now, if I would say take that out, right? We see there's a, and this is caused because of the phase is not being corrected. So this means that this is not properly implementing a control +1, because I cannot uncompute it with a control -1. The goal is here, you're trying to create something just to test that, right? And you want to test it with something you know how to make the inverse of. But this specific piece is related to the +1, and this specific piece here is related to the +1. So effectively, you cannot just, in general, implement a control of this random thing unless you know these things, right? Unless you know how to do the phase correction, unless you know how to prepare this eigenstate, because you want these not to have any effect. Like, you want this gate to have no effect should the qubit be 0. The control qubit be 0, because when the control qubit is 0, let's just go through this again. So when the control qubit is, yeah, well, that stays basically the same, because if it's a 1, then it's gonna go here. So you're putting this state temporarily up and then down again. If it's 0, you want the state to go through and stay the same, and you don't want this to have any effect on that at all. And that is obviously entangled with this, because that's kind of the final effect you want to have is that of a control knot, right? So the 1, yeah, that is correct. But I'm quite surprised, because I would always assume that this should work as well. And if I uncompute the thing, the thing is, I don't get stuff. Oh, wait a second, that works? No, that doesn't work. Oh, that works. Oh, I'm so stupid. It doesn't work. No, wait a second. Does it work here? Doesn't it work here? I don't know why it doesn't work here, though. It should work here as well. Come on. You applied Harman gates. And you applied Harman gates. That should work. Why it doesn't work? Why it doesn't work here? I don't know why it doesn't work. It should work. Yeah, that's the trick. So this is really, how complex it is, how tricky it is to actually build some of these things, because it's really essentially like you gotta consider Like that's a funny one because you got to consider really here the phase kickbacks and stuff, and you want to design that in a way that you know that you're doing exactly what the gate is supposed to do. Even if you're using ancilla qubits, you also should clean them up. Like you should also make sure that they stay as they are. You can use them temporarily, but you should always kind of reuse them. Now that's why you kind of have to do it. I think this is a way smarter way to build out with this, like a swap sandwich, so to say. And then this bunch of gates here I'm just using to kind of test that that it computes, and there's no phase problems. Yeah, but there is obviously a problem. There's obviously a problem with the usage of the Hadamarts here, which I have to still figure out. Okay, but I feel a bit more confident now. So if I use these two, now I get it off completely, and so I should have Hadamard here. Now he's adding yet another test, which is he's doing this like funky entanglement in here, which I don't know why, but I don't know what is he testing. Like, what is he really testing with these? That's what I don't know. But I have to figure out. Now I understand the sandwich. I understand these. The plus one doesn't have any effect in that, but it should have. That's what I don't understand. I thought it should have actually. We'll probably have to do this by hand. I just like, am I that stupid? Am I really that stupid? Like if I have these and the QFT, right? And now I apply the plus one gate. Why the heck doesn't this? Yeah, well, it does. Okay, but it's just adding. Well, it does. Okay, I get it. So it does, but that's why you have to have that correction, that phase, because this is essentially the same state. It just has a global phase of exactly like S. So if I, yeah, now it works. So, okay, so this is not only, so this is not only dependent on these, but it's dependent on these as well, because it's really, you got to correct for the phase kickback. You got to correct for the phase kickback that these in combination with these is adding to the whole mix. So if you find an eigenstate where it doesn't add a global phase, then you don't need that. And now this makes sense. Good. I'm happy. I get it. Now what I don't fully yet get is this part. What is this supposed to be testing? Is it supposed to be testing that if I mess up here, nothing happens, or what's the point? I don't know what the point. I don't know what's the point of these. I'll have to play with that. But now I get. Okay, now I get it. Cool. Perfect. We'll stop here.